I work for a company called Cons of Solutions in India. I'm primarily into the consulting space on Microsoft technology. Over the last few years, I'm focusing on mainly on SharePoint development. My background is pretty much on the development side. I have little background on the administration. So today I'm going to talk about SharePoint 2010 Sandbox Solutions. This session will cover a brief overview of what a sandbox solution is, how the sandbox architecture or the sandbox framework is built up, and what are all the restrictions in a typical sandbox environment, what are the best practices to be adopted or to be considered while developing the sandbox solutions, and I'll also quickly show you a demo how we can leverage, how we can get out of the restrictions posed by the sandbox solutions, how we can reach to the external world objects through the sandbox. So with that briefing, I'm directly jumping onto my session. So, I mean, in a nutshell, in a brief, the sandbox is all about, it's an environment where your piece of SharePoint code is executed with restricted set of permissions. So, in terms of a .NET developer's understanding, what we can say is a sandbox solution typically has partial trust permissions. It is not a full trust assembly like the other ones, like the form solutions. And of course, there are many more restrictions, with respect to the sandbox solutions. I'll cover them later in detail in the coming slides. I mean, see, there are, in SharePoint 2007, we had the concept of, we had only the concept of the form solutions. There were many, disadvantages, with only the form solutions, because if you're a large organization and you have multiple groups or departments within your organization are adopting, SharePoint, and they are doing a lot of custom development in terms of, custom web parts, event handlers, workflows, things like that, it becomes completely a nightmare for all the, for the entire set of the administrator group to monitor all these components if they are deployed as a form solution. I think the major challenges were, since most of the solutions, since all of the solutions were deployed as a form solution in SharePoint 2007, all of them had to go to, go to the GAC, or the assemblies have to go to the GAC, or the components like the user controls and the application pages, they have to be deployed to the file system. And if it's a shared environment, because I've worked with many customers, many global customers, where they have built huge, humongous SharePoint platform, which caters to, thousands and thousands of users. For instance, we had a customer whose collaboration stack was SharePoint, and 70,000 users using the SharePoint platform, be it as an application platform, development, or a collaboration platform. In such cases where multiple department adopts, then there will be a lot of challenges in terms of maintaining them, monitoring them, and there is also a high risk of, multiple form solution deployment can lead to, disaster to the SharePoint form. So, and again, I mean, with respect to the, administrator didn't have much control about the form solutions, because, for example, in a form solution, administrator, doesn't he doesn't know whether he can trust this WSP before deploying it. He doesn't know whether how much of, memory or RAM, CPU, the threads, the processor, and all those things is going to take. So there are a few tools which he used to, the administrators used to check before deploying the code as a form solution. But with the introduction of the sandbox framework in SharePoint 2010, that has eased a lot of things, from the administration perspective, and it paves the way for a better monitoring. Just one moment. There is some problem with my slides. And one of the other scenario where, sandbox solution can be adopted is, with the advent of the new cloud technologies, be it the BPOSD or the latest Microsoft SharePoint cloud platforms like Office 365, where it's a shared environment, it's a multi-tenant architecture. Most of the times we don't get a dedicated setup or a dedicated environment. In such cases, the concept of sandbox solution is very well tailor-made for all the cloud solution. Typically, in an Office 365 kind of a deployment, you have various plans, starting from E1, E2, E3, up till it goes to E4. And most of the time, the customers or the end organizations, they go for either E1 or an E2 plan, where they get only access to a site collection on the Office 365, where they don't have access to a front-end server or they don't have access to an IaaS server. So in such cases, sandbox solution makes a lot of sense, to be adopted. And so during the initial slides, so I've discussed about the limitations I briefed about the limitations of sandbox solution. So there are a couple of, at a high level, there are a couple of limitations about sandbox solution. One is there are restrictions within the SharePoint framework assemblies, what are the stuff it can access. And there is a second set of restriction, which is set of things which cannot access outside of the sandbox solution. So first, let's discuss the first restriction. The first restriction is a sandbox solution has something called a subset assemblies. Sandbox, a typical SharePoint 2010 sandbox solution does not have access to Microsoft the SharePoint.dll. So typically, when a sandbox solution is uploaded and it is deployed in the SharePoint server, the way it works is, the end user, he makes a request to the IaaS, to the browser, which in turn passes the request back to the IaaS. On the IaaS, there is a component called http.sys, which is a generic driver which receives the request for both ASP.NET, SharePoint, and other ASP.NET compatible application. Then what it does is it forwards the request to a SharePoint execution manager. The SharePoint execution manager then evaluates the request, and it figures out whether the request is from a SharePoint Forms solution or it is from a SharePoint Sandbox solution. If the request is from a sandbox solution, what it does is it altogether follows a different execution path. So what it does is it makes sure that the entire sandbox assembly is not something executed or delivered by the W3 WP process. Typically, an ASP.NET application or a full trust SharePoint solution which is executed by W3 WP process. In this case, what happens is once the request is received, the SharePoint manager diverts the request to something called SharePoint SPUC worker process, which is a typical sandbox worker process, which caters to all the requests of a sandbox solution. Inside the worker process, it takes care of applying all the restrictions and as well as the code access security policies. The SPUC worker process makes sure that the sandbox solution does not access to the regular Microsoft.SharePoint.dll. Rather, what it does is it takes a detour and it routes to another version of Microsoft.SharePoint.dll, where only a subset of the functionalities provided by the SharePoint object model is available. Typically things like SP site, SP web, SP list, SP workflow, those kind of things are available, whereas the functionalities like SP form, SP administration, those kind of APIs are not available in a sandbox solution because of this restricted Microsoft.SharePoint.dll. Again, the way the sandbox framework is built up is that the entire sandbox assembly, which is subject to the CAS, the .NET Code Access Security Policy, where it is partially trusted assembly, where it has many more restrictions. In the forthcoming slides, I'll discuss in detail about what are all those restrictions and how it can be. So typically, this slide covers about a life cycle of a sandbox solution. So there are 4 stages in the life cycle of a sandbox solution. The first stage is the installation, the second stage is activation, third is a deactivation, and fourth is deletion. So the installation phase, what we typically do is we upload the sandbox WSP onto the solution in gallery in the at the site collection level. It can be done manually or it can be done through a PowerShell script. Activation, again, activation can be done. Activation, again, it is the process of activating the WSP files on the solution gallery of the site collection. This again can be done through manually going to the site collection gallery and then click the activate settings, or it can be done through a PowerShell. So this is the sandbox solutions, can be administered through the central administration. What we can do is in the sandbox solution, there are with respect to the administration, there are two processes. One is the process of applying the quota templates, and the other is process of blocking or unblocking the sandbox solution. The first one is where there is an option where an administrator can go and specifically block a poorly performing sandbox solution. The second process is quota templates. Quota templates is again provided by the sandbox infrastructure, and it is determined based on 14 or 15 parameter, what we call it as 14 or 15 point parameterized quota, where it has a default value. The administrator can go and he can select the default values, or he can go and increase or decrease the default values. So conceptually, the significance of these quota templates are, the way the sandbox works is once the sandbox components or the sandbox WSPs, it reaches this quota and it tries to exceed it, the sandbox frameworks tries to block the execution of the component. And there are three levels where this blocking can be done. I'll explain it later at the end of the slides. And this slide actually, details about what are all the subset object model which is available to sandbox, which is not available. As I said earlier, the Microsoft.SharePoint.administration and Microsoft.SharePoint.webcontrols SP form, those objects are not available in the sandbox solution. And so with respect to the sandbox solution, there are three processes which we need to be aware of. The first one is SPUC host service.exe. Second is SPUC worker process.exe, and the third is SPUC worker process proxy.exe. The first component, SPUC host service.exe, which forms the backbone, or it is the backend of the entire sandbox infrastructure, and this need not be installed on the same front end, or it need not be in the same machine where the web front end components of the SharePoint 2010 is installed. So while installing it, the administrator has the flexibility of choosing where they want to install. Typically, this SPUC host service process, the administrators prefer to install them on an application server or a middle tier server. And the second one is the sandbox worker process, and this is the actual process which takes care of the catering to the request from the sandbox solution, and then it processes the entire request and it delivers the response back to this calling program. SPUC worker process is analogous to W3WP.exe for a typical SharePoint 2010 full trust solution or a ASP.NET application. The third is sandbox worker process proxy. So there is a concept called full trust proxy. The full trust proxy, which helps the sandbox solution to reach to the external objects, things like web services, things like WCF service, database calls, file IO, networking, buffering, streaming. Those kind of functionalities are not available by default in a sandbox solution. So let's say if we want to implement such functionalities, what we can do is we can create a full trust proxy. Full trust proxy, again, we need to create it as a farm solution and register them at the farm solution level. This full trust proxy gets executed within this component called SPUC worker process.exe. So with this briefing, we'll move to the next slide where we discuss about how it is executed. So this slide talks about how a typical sandbox solution is processed with respect to the code security policy. The way it works is, the sandbox assemblies or sandbox solution, it is partially trusted by default, and once we need to reach out to the external world or external objects, we will be creating a full trust proxy. The full trust proxy is full trust by default, but what we need to make sure is that we need to make sure allow partially trusted callers attribute is applied to the full trust objects. And while creating the full trust proxy operations and full trust proxy classes, we need to make sure that ASP.NET hosting permission level is set to minimum, and SharePoint permission is set to true, and security permission is flags is set to execution. And sandboxing architecture. So this is the one which I already explained. This slide quickly pictorially illustrates how it works. So typically these sandbox components, the host service, the worker process, and the proxy, all of them actually lives in a backend or an application server. From the front end, the request gets forwarded. So while installing, there are a couple of options where the administrator can choose. Let's say if an administrator chooses to install the SPUC host process, SPUC worker process, and the proxy on the same machine. So what they call it as, they set this to a local execution mode, so that all the requests of that particular front end for a sandbox solution is forwarded to the corresponding SPUC worker process, which is sitting on the same machine. And the administrator can also choose to install this SPUC host process, SPUC worker process in a separate server, where they have to set this affinity to be remote, so that whenever request is received on the front end, it is forwarded to a corresponding remote app server where this process is executed. And so this slide typically talks about a process of how a sandbox solution is uploaded. And typically a sandbox solution is uploaded, and the assemblies and other related components are deployed to the solution gallery. So which means the assemblies, in turn, they are pushed to the database, and there is a concept called per WFE assembly cache in Sandbox Solution, which means whenever a Sandbox solution is requested, all those assemblies, all those required Sandbox assemblies are internally cached at the per WFE level, so that the subsequent execution is faster. And so this assembly cache, it is not perpetual. So once the Sandbox solution is terminated or it is retracted, automatically the per WFE assembly cache, it is cleared. So there, in the SharePoint 2010 product, there is an algorithm which frequently scans the presence of these the cache assemblies for a sandbox. And if a sandbox solution is retracted, this algorithm automatically clears those assembly from the per WFE assembly cache, so that it doesn't have the older copy of the sandbox assemblies. So the primary essence is that in the sandbox solution, where it cannot reach the file system or we cannot deploy the underscore layouts folder, the components to the underscore layouts folder. So initially, when SharePoint 2010 was released, we did not have the option to even create a visual web part using a sandbox solution. So after a few months, Visual Studio team, they released something called Visual Studio 2010 Power Tools for SharePoint. So with the help of this tool, we can now even create visual web parts as sandbox solutions. So as of today, the components like visual web parts, event receivers, feature activation events, custom workflow actions, and other things, they are supported in sandbox solution. Things like application pages, they are not supported, and the declarative workflows, they are supported in sandbox solution. One of the restrictions in a sandbox solution is that it cannot reach to the Microsoft.SharePoint.security namespace. So this is again a cache. And so till now we are discussing about all the internal restrictions with respect to the Microsoft.SharePoint and other SharePoint ecosystem related assemblies. Now we'll talk about what are all the restrictions to the .NET framework assemblies, with respect to the Sandbox solution. So as we said earlier, Sandbox solutions can only reach to a partially trusted assemblies. So about 2/3 of the .NET 3.5 framework assemblies that cannot be called or invoked from a Sandbox solution. This is a statistics which is given in MSDN. So close to one third of assemblies which can only be, of the .NET 3.5 assemblies which can be called inside a Sandbox solution. So things like if you want to create a HTTP web request, HTTP web response, if you want to do a CASPAL code access security manipulation, if you want to programmatically create WCF endpoints, if you want to host a workflow, if you want to do a file IO, if you want to write to a event log, so a lot of those, real world, the most common development scenarios, they are not supported in the Sandbox solution as of today. This slide talks, this slide pictorially illustrates what are all the restrictions, what are all the boundaries which a typical Sandbox solution cannot reach. I think one of the other thing, major restriction in a Sandbox solution is that a Sandbox solution cannot invoke an unmanaged code. So, and one of the key points which we need to be aware of is that the way we need to understand how the Visual Studio IntelliSense handles the Sandbox solution and how the assemblies or the types which are referred inside the Sandbox solution, they are deciphered at the runtime. So Visual Studio IntelliSense uses IntelliSense to hide full trust types, but still Visual Studio doesn't prevent us from adding any assembly which is not supported by a Sandbox. So during the compile time, it doesn't throw any error because during the compile time Visual Studio doesn't have a support to check the Sandbox, but only at the runtime when we try to add a web part from a Sandbox gallery to a web part page, so at that time it figures out all the permission levels and then it spits out the corresponding error. So it is better actually to apply some thought process before even considering the scenarios for the Sandbox development rather than doing a lot of coding and then uploading it to the portal. So this diagram pictorially represents an architecture of how the full trust proxy operations works. So as we said earlier, the full trust proxies are components which helps us to reach the external objects or the objects which cannot be typically called from a Sandbox solution. So there are few steps which we need to consider while creating a full trust proxy. So first what we need to do is we need to create a full trust proxy project in Visual Studio. It's just a simple class library project, and then we need to create a couple of classes or types. One is for proxy operation, other is for proxy operation arguments. So before that, what we need to do is we need to go to the assembly.info.vb or CS file, and we need to make sure that this full trust proxy project or assembly is accessible from a partially trusted caller, the Sandbox component. We need to mark that attribute. Then we need to create a couple of classes. One is Sandbox operation arguments. Here we need to create a class which inherits from which inherits or implements SP proxy operation args, and then we have to create bunch of properties or the arguments that we need to pass to a SP proxy operation class. Then what we need to do is we need to create a brand new class. This is the class, or this will provide a method which will have the functionality to handshake with the external world objects. Here this class needs to inherit from SP proxy operation class, and we need to override a method called execute. We need to override this execute method, and inside this execute method we can write all the full trust code, whatever we need to do. And then we need to compile and deploy this. The more importantly, this Sandbox full trust proxy needs to be created as a form solution, and it needs to be deployed to the form solutions gallery. And there are a couple of few points which we need to be aware of. One is the user who deploys this full trust proxy, he should be a member of the form administrators group, and as well as he should be a part of the administrators group of the corresponding box where this assembly is deployed. And other point what we need to make sure is that the SharePoint 2010 administration service, you need to make sure that SharePoint 2010 administration service, a Windows service, which is started before deploying this. And after deploying these assemblies, we need to restart the Sandbox SPUC worker process.exe so that it gets refreshed with these assemblies. And after that, the process is simple. From the Sandbox solution, what we can do is we can use this sputility.execute register proxy method that would invoke the registered proxies, and then it can call this. So this is just a brief overview of how we can create a full trust proxy. I will quickly jump onto a demo where I'll explain how we can create a full trust proxy. So I'm just jumping onto the typical SharePoint 2010, the information worker virtual PC, which I use for all the training and demonstration purpose. So I have a web part, a Sandbox web part, by name SharePoint Saturday web part. So the functionality which I'm trying to showcase is very simple. The functionality of the web part or the functionality of the component, it is immaterial for this demonstration, but I'm just using these sample components to demonstrate the concept, how a Sandbox solution works and how we can deploy this. So I have a requirement where I need to invoke a WCF service from a Sandbox solution. Let's say if I directly try to invoke a WCF service, there are two methods for invoking a WCF service. One is that we can do a right click in Visual Studio, add a proxy, and then try to invoke it. Or the other method is where we can programmatically, generate the proxies, programmatically create the endpoints, generate the proxies using SVC util, and try to execute it. So if we follow either one of the approach in a Sandbox solution, try to add it to a web part page, it will spit out an exception because it will give system.net.web exception saying that this particular operation is prohibited inside a Sandbox solution, because at runtime, when the SPUC worker process tries to execute the Sandbox solution, it has its own code access security policy, which is defined in WSS under user and under minimal config file, where these operations are restricted. So this presents a classical need, for the full trust proxies. So what I need to do is I have decided to create a component, a full trust proxy, which I've already created. I'll be just walking through the code, and after the end of walkthrough, I will just demonstrate how it works. So I have a full trust proxy which I've created here already, by name simple proxy, and this proxy has all the full trust permission. It will try to invoke the WCF service. Okay. The proxy project is loading up. I'll flip over to the WCF service project. So I have this WCF service by name credit card service, and the file name validation service.svc. And if I try to open up this service, the implementation is very, very simple. It just tries to do a get free, takes an integer and then returns a hard-coded string. So, the implementation is just immaterial. So what we are trying to do here is, this is an IaaS hosted web service. I created this web service and hosted in IaaS. The port where it is running is 1414, and I'm using WS HTTP binding, for this WCF service for a few reasons, which I will explain, later in this talk. So right now we have this WCF ready, and I have simple proxy, which is the full trust proxy, which I am creating. As I said earlier, the first step what we need to make sure is that we need to go to the assembly info.cs file, and then we need to make sure that allow partially trusted callers. This attribute is set to true. I mean, this attribute is set. If you don't set this attribute, so this will not allow a sandbox solution to invoke this proxy. And next what we'll be doing is we'll be creating the sandbox proxy operation, I mean the proxy method, and as well as the argument. So first we will define the argument. Argument is nothing but set of bunch of parameters that we need to pass to a sandbox solution. So what we do is, you can provide any arbitrary name. There is no hard and fast rule or which naming convention you need to follow. So what I'm doing here is public class simple proxy, just a name I've given, and we are inheriting this from SP proxy operation orgs. If you note it here, we mark this proxy class with a serializable attribute. Actually, all the proxies needs to be marked with the proxy arguments need to be marked with a serializable attribute. We don't need to mark proxy operation class with the serializable attribute, because only if you mark this with the serialization attribute, it will be serialized across the wire or across the physical tiers where you send this object. So this again goes back to the basic concepts of the distributed computing, what we typically do about the serialization and marshalling. So we have created the proxy argument, and I need to pass just the parameter, I mean the country ID. So what I have said is I have just defined an integer property as a country ID, and in the proxy argument itself I'm creating a couple of more properties. One for proxy operation type name, other is a proxy operation assembly name. So basically these two properties will be used by your sandbox web part to understand what is the assembly name of the full trust proxy, or to understand what is the method which is, or the operation which is declared in the full trust proxy. So what we do is, here I know that the namespace is simple proxy, and the class is the operation class is simple proxy ops, and here I'm giving a fully qualified assembly declaration, the assembly name, the version, the culture, and the public key token. Next what we do is, after declaring the proxy argument, we go to the proxy ops, we go to the proxy operation class, and here we create any arbitrary class. The name of the class is immaterial, and we need to make sure that the proxy operation is inherited from SP proxy operation, and the SharePoint security permission, the .link demand object model is set to true. So here what we try to do is, the basic concept is we need to override the execute method inside this proxy operation, and then whatever full trust operation which we want to do, we can do. I mean, here we can even talk to a database, we can connect to a database, we can connect to a file system, we can do a buffering, we can do a streaming, we can invoke a service. All those free operations are possible here. So here what I'm trying to do is, so I will just take a brief pass for the first section of the code. I'll reserve my comments later. I'll go to the later section of the code. So what I typically do is, I have this. What I'm doing is, here in the full trust proxy, I'm trying to refer to the proxy argument class, and I'm trying to get the country ID, because I need to pass this to the actual WCF servers. So meanwhile, I'll show you the WCF servers, the proxy. I mean, here there are two proxies. One is the WCF service proxy, and the other is the full trust proxy of a sandbox solution. We should not be confused with these two. So I mean, as in a typical service oriented world, or a typical service oriented architecture, where a proxy is involved, which enables the communication between a client and the endpoint of a server. So with that briefing in mind, we created a proxy. So there are two ways of creating a proxy. One is we can create a proxy class for a WCF service using Visual Studio. We can do a right click, then add a service reference. So with this option, we can create a proxy, and there is other option where we can use this SVC util, which is a command line utility where we can generate the proxy. But personally, I would prefer and I would recommend to create the WCF proxies using the svcutil.exe for many reasons, because svcutil.exe gives a lot of flexibility and a lot of control while generating the proxy files. So one of the advantages what I can tell you is that if you use svcutil.exe to generate proxy files, I mean, you can decide what should be the framework version, .NET framework version, to which this proxy needs to be targeted. So I can choose a .NET 4, .NET 3.5, .NET 2. So it depends on your client. I mean, you can decide what should be your target. I mean, your version of your proxy. And the other thing is what should be the namespace against which, or namespace correlation against which this proxy needs to be created. So if you don't specify a namespace while creating a proxy using the svcutil, you will not see the WCF service proxy class, the client class in the calling program. So here the proxy client is validation service client, which in turn has all the code. I mean, here if you go here, OVSC, this object. So it has a method called get country, and then it tries to pass all that. So we need to make sure that we need to set a proper namespace while generating svcutil, while generating the proxy using svcutil. If a proper namespace is set, then we'll be able to easily access the proxy, the WCF proxy file inside this full trust proxy argument without having any service reference or any namespace reference inside this code. And the next logical step is, we have created proxies, and what we are doing is we are invoking this WCF method, and then we are passing the argument, then we are returning the result back to the calling program, which is the Sandbox solution. So while generating the client proxy for a WCF service, typically we get an endpoint. So in the WCF world, we have an endpoint for server, we have an endpoint for client. So I mean, while I generate the a proxy using svcutil, it gives me a config file by name output.config. This is the content which will be there in output.config, and I just rename this file to a app.config. So what we can typically do is we rename this one, and if you directly compile this, and then if you're all set to run, boom, it will actually break, because it will not understand. Basically it will say that the service with the so and so endpoint is not found. So what is the process of figuring out the endpoint in this one? There are two ways where we can really make sure that this calling component of the WCF service understands this endpoint. So had it been a web related component like a SharePoint web part, SharePoint application page, or maybe an ASP.NET plain .NET page, what we can do is we can copy the contents of this proxy file, and then we can go and deploy this under the corresponding web.config file at the IIS, and there will be a section called system.service model. We'll copy the binding section, and we'll copy the client section, and we'll go to the IIS. Basically there will be IIS website under 1414 port, and we can copy this, we can paste it, so that if it is a web component like a web part or a application page, it automatically fills out the endpoint while calling the client. But for the Sandbox full trust proxy is typically doesn't get executed under the context of W3 WP. So that way of informing this WCF endpoint will not work. So what we need to do is, we need to really spend some time in programmatically creating the WCF endpoint. We need to programmatically create WCF binding and WCF client and all the endpoint URL. So that's what I have done in this proxy class. If you look at this class, what I've done is, so my server is set with a WS HTTP binding. So I'm applying a WS HTTP binding, and then I'm trying whatever is there in this config file. Exactly, I'm trying to match all the attributes one-to-one or one-on-one here. I'm trying to do a lot of coding and create a binding, and as well as I'm trying to create an endpoint address. After creating this binding, basically we need two objects. One is a binding, and other is an endpoint address. Once this is ready, can pass these two things while creating an instance of the WCF client proxy. So here I pass this WCF HTTP binding and this endpoint address, and then I'm free to go. I can invoke this one. So what I do is, if you go to this one, go to the portal, I click here. So I mean, it tries to call this. It tries to call the full trust proxy, and then proxy in turn calls the W service, and then it returns the value India and then returns it back. So I'll just flip over to the slides quickly. Okay, and we will talk about now we'll talk about how we can administer a sandbox solution. So like, can anyone really go ahead and upload the sandbox solution? How do we make sure that this is not a nightmare for administrators? So only people who have site collection administrator access, they can upload a sandbox solution. Again, sandbox solution is completely controlled or administered or governed through a strict quota policy, which is a 14 or 15 points quota, and each parameter a limit will be set. So there are three modes of breakout. One is, let's say if you're doing a long running operation inside the sandbox code. For example, if the sandbox code executes more than 30 seconds, what the sandbox framework will do is it will automatically shut down the execution of the component. That is one way of doing it. That is actually per request. Basically, it will evaluate how much CPU time, how much memory, or how much resources it takes per request, and then it will automatically shut down the component after 30 seconds of continuous execution. So what it conveys is that typically sandbox solutions are not preferred for a long running operations. There is another method where we have 14 or 15 point parameters set. I'll walk through what are those 14 or 15 parameters later in the slides. So let's say if one of the parameter which reaches the threshold or the quota, automatically it stops that corresponding component from execution. And of course, the administrator has his own privileges where he can pick and choose a particular sandbox solution, and then he can completely disable that from execution. So these are, again, the quota again can be used per day, or it can be used based on the individual resources. So there are multiple options available for administrators. So these are the quota which I spoke about, which is I think close to 15 points. I mean, typically what we need to worry about is CPU execution time, critical exception count, process CPU cycles, the process thread count, SharePoint database query count, and all that. Because CPU is something, CPU and memory utilization is something which we need to be, diligently aware of it. And one of the big challenge of a sandbox solution is that, of course, there are not much tools, or there are not much straightforward way where you can really go ahead and do a CPU sampling, for a sandbox component. Basically, you cannot easily or quickly find out how much CPU cycles or how much percentage of CPU it occupies over any period of time. There are methods available which I will brief it at the end of the slide. So these are the basic quota, and the administrator can modify the quota, and if the quota exceeds, basically it calculates either if the quota exceeds instantaneously, or if it exceeds collectively at the end of the day, the corresponding application or the solution will be shut down. And this sandbox solution can be administered through PowerShell. The quota can be viewed, or it can be updated through PowerShell. This slide just briefs about you can typically take these PowerShell scripts, try to use it in the PowerShell manager. You'll get all the quota available in the site collection. This is pretty much. Now I have a couple of more slides to cover before I wind up. So how do you do debugging for sandbox solution? So it is again similar process like how do we do debug for a typical full trust solution or a typical any .NET component. So the only thing is where you want to attach the debugger process, that is the different. If it is a full trust solution, we will be attaching the debugger to the w3wp.exe. Here in the sandbox solution, what we need to do is we need to attach the debugger process. Basically, open up the sandbox solution in the debug mode. Go to tools, click the attach to processes option. Then you find out the spuc worker process.exe and then attach the breakpoint. So basically, this will make sure that the breakpoint is attached to the sandbox worker process, and then it will help you to debug the sandbox solution. The other option is let's say if you want to debug a proxy associated with a sandbox solution, it can be done, of course. What we need to do is, in this case, instead of attaching the breakpoint to spuc worker process.exe, we need to attach the breakpoint to spuc worker process proxy.exe. And the next slide, where we talk about how to profile sandbox solution. So as I briefed earlier, like a couple of slides back, and there are not much straightforward way available to profile a sandbox solution. So after Visual Studio Service Pack 1, there is a tiny component which was released, which is called Visual Studio Standalone Profiler for Visual Studio 2010 Service Pack 1. So we need to download this. Probably it might be there, if you have Visual Studio 2010 Ultimate Edition with all the performance tools available. So what we need to do is we need to navigate to the corresponding directory where you have installed the Visual Studio, whether it could be C program files or it could be D program files, and you need to go to the corresponding directory where a 64-bit version of the VSPerf CLR environment, VSPerf command tool is installed. Then what we need to do is, we need to, for first two steps, we need to turn the global sample on, and we need to turn on the global interaction on. This sets the environment variable, and it makes sure that you have done all the prerequisite steps to profile the sandbox solution. Then we need to restart the server. Then what we need to do is we need to invoke the VSPerf command and pass the necessary parameters, where we would be providing an output. So output would be typically a file with an extension .vsp. Where the .vsp file is a typical Visual Studio Profiler output file. And then after that, what we need to do is the step 5 and the step 7. These are very important, where we need to attach the Visual Studio Performance Profiler, the VSPerf command tool, to the corresponding sandbox process. So here what we need to do is we need to invoke VSPerf CMD tool with an attached switch, and we have to specify either the process name or the process ID. Usually it is recommended to specify the process ID. So how we specify the process ID is we go to Visual Studio, and then when you try to attach a debugger to a process, then in the window we'll find out what is the process ID corresponding to the spuc worker process.exe. Now once we figure out the process ID, in my case today the process ID is 2380 or something, then I supply the process ID, and then what I do is I need to browse to the necessary page where a sandbox solution is hosted, and then I'll click do all the necessary operation. Once all the necessary work related to the sandbox solution is done, all the necessary transaction related to sandbox, it will spit out the VSP report, the CPU profiling report on this location where we specified. Then what we need to do is we need to detach the VSPerf CMD tool, and we need to shut down this entire process so that this is not running in an unwanted manner. So this is pretty much how we typically profile the sandbox solution. So I'm pretty much done with this session. Are there any Q&As?
Thanks a lot, Sundar. We'll wait for a couple of minutes to see if there are any questions for you.